Dear students, now I'm going to tell you about the another biotechnique, spectrophotometry. You might have studied already in your chemistry. So spectrophotometer, this is the device, is an instrument used to measure the concentration of solutes in a solution by measuring the amount of light absorbed by the solution. So the solution for which we wanted the concentration, so we will measure the amount of light absorbed by the solution that gives the concentration of that particular solutes. So this is a simple technique that is for the first time invented by Arnold Beckman in 1940. So this spectrophotometer is commonly used in almost all chemistry, physics, biology, biochemistry, engineering, clinical labs, even in the industry, for qualitative as well as the quantitative analysis of the substance in a solution for which we wanted want to test. So this is in this you will see what are the parts of this. So there will be a screen. You will see this gives the optical density or the absorbance. This is where the sample can be placed. This one, the sample holder. So then on and off switch. Then we can fix the wavelengths. This is the knob. We can fix the wavelengths. So that is the digital screen. So all these are the parts of the spectrophotometer. So spectrophotometer, the principles, basically what are the parts of the spectrophotometer? So it consists a light source. This is the light source. So this light source pass through a slit, entrance slit. It fall on the prism. So the prism splits the light into different wavelengths. This you will see here. This and a slit through which narrow beam of the desired wavelength passes. So depending on the color of the substance, so color of the sample, we have to decide in which wavelength we have to we have to pass. So we can able to adjust. So the which wavelength through this there will be a adjustment. So the desired wavelength can be passed through to the sample. Now this incident light, it passes through the sample and it transmitted light can be detected in a detector. So this is the parts of the basic parts of the spectrophotometer. So first we have to measure the absorbance of the blank solution. So without any sample, without any the content for which we wanted to assess the quantity. So it is a blank. Then we have to keep the sample. Then we have to check the absorbance. So we have to detect the sample absorbance with the blank one. So this is what you can see. Measure the intensity light passing through the sample. Calculate the transmittance. So calculate the absorbance. All these we can get in the screen. Then we have to apply the Lambert Law to calculate the concentration of the solute in the sample or else in the solvent. So the spectrophotometer diffracting the light beam into a spectrum of the wavelength. So you will see there is a prism. So this prism is used to split the incident beam into different wavelengths. So what you see here in the picture. So when the light passes through a solution, a certain fraction is being absorbed. This fraction is detected. A fraction is you can see it is get absorbed and this fraction is detected in a detector. Okay, so it is measured and used to relate the light absorbed or transmitted to the concentration of the substance. This enables both qualitative and quantitative analysis of the substance. So this is how we can able to measure the amount of light absorbed, then amount of light transmitted. So from this we can able to analyze the quality of the solution, quantity of the solution. Quality means what type of the component dissolved in it. So that is how. This enables both qualitative and quantitative analysis of the substance. Spectrophotometric technique involves diffracting the light beam. You will find the prism. Then we have to choose the wavelength for which we want to pass, because depending on the color of the solution, then that light will be passed on the sample. Then after that you can see the light is transmitted and the detector will able to detect the amount of transmitted light, and we can also analyze the absorbance, whatever absorbed from the solution. So the light absorbance is directly related to the concentration of the compounds of the sample. So whatever the amount of the light absorbed depends on the concentration of the solution. The concentration increases, light absorption increases linearly. So you will find the linear graph. As the concentration increases, the absorbance also increases. As concentration increases, light absorption increases linearly, and transmittance or the transmission decreases. The amount of light passes out of the sample decreases. So you will find this is the decreases in a exponential rate. So the initial light intensity, the photon, that is the light, it is the photon of the monochromatic light, that is it is called I0, that is going to passes through the unknown solution. Some amount of the photon is absorbed by the solution, that is the solutes that is present in the solution will absorb some amount of the photon. Light after passing through the solution, this is the IT. This it will be detected in the digital display, that is the detector will detect and it will be displayed. So the transmittance, that is the transmitted light that is passing from the solution, and absorbance, the amount of light absorbed in the solution, can be estimated or can be calculated. The transmittance is simply the fraction of light in the original beam that passes through the sample. So it will be appear in terms of fraction through the sample and reaches the detector. The transmittance T of the solution is defined as the ratio of the transmitted intensity IT over the incident that is called the incident light I0, and there is a transmitted IT. So the transmittance is equal to IT divided by I0, that gives the transmittance of the light. So the absorbance can be used to relate the concentration of the solution. Absorbance can be related to the amount of the substance in the solution. So that is what you can see, the incident light, some amount absorbed, then you can see the transmittant light. So it is the amount of the absorbed light, it is related to the concentration of the solution, concentration of the substance in the solution. Thus it can be used to quantitatively determine the amount of the substance that is present. The absorbance has a logarithmic relationship to the transmittance. With an absorbance 0, there is, if the nothing is absorbed means the 100% transmittance, because the incident rate directly transmitted. If some amount absorbed, the intensity decreases. So that is the negative logarithmic relationship. So if the absorbance is 1, that means it is the transmittance is the 10%. So this is transmittance is equal to IT divided by I0. So absorbance is, that's why the negative logarithmic of transmittance. So this is the mathematical formulation we can derive from this relationship. So what is we have to apply Lambert Law to calculate the concentration. What exactly Lambert Law? It states that there is a linear relationship between concentration and the absorbance of the solution. Depending on the concentration, the absorbance of the light in the sample, which enables the concentration of the solution to be calculated measuring the absorbance. The molar absorbance coefficient. So absorbance efficiency of a sample at a particular wavelength of a light, that is the molar absorbance coefficient. The concentration, that is moles per liter. So that is called M of the sample dissolved in the solution, and the length of the cuvette used as typically 1 centimeter. So we can derive absorbance is equal to epsilon into concentration into the optical path length. Epsilon is the molar absorption coefficient. Then concentration we can calculate. Absorbance we will get from the spectrophotometer. You know the optical path is always 1 centimeter. So there, by using this formula, we can able to calculate the concentration of the solution through this spectrophotometer. So what are the applications of the spectrophotometer? Spectrophotometer is an analytical instrument used for detect the concentration of the substance. As I said, any substance we can concentration can be detected using this spectrophotometer. Then we can elucidate the structure of the organic compound. So we can see there is a display. There is we can get the graph, and we can get this lambda, and we can able to assess. Here this is what you can see. What is the organic compound? We can from this the peaks and all this graph, we can able to deduce the structure. So we can also monitor the dissolved oxygen content in the fresh water by using this spectrophotometer, and also in the marine system. Then characterization and concentration of the proteins, the amount of the proteins dissolved in the solution, and amount of the enzymes dissolved in the solution, amount of the nucleic acid, DNA dissolved in the solution. All these we can set the different wavelength. That's it. We can able to measure. Then the measurement of respiratory gases in the hospitals. So they use spectrophotometer. Molecular weight determination of a compounds by preparing suitable derivatives. So we can able to measure the molecular weight of the compounds. Then the visible and UV spectrophotometer may be used to identify the classes of the compounds in both pure state and also in the biological preparations. Spectrophotometer detect the free nucleotides, nucleic acids, DNA, RNA. So many substance concentrations can be detected using the spectrophotometer. So it is also we can also detect the impurities of the compound. You will see in this the UV spectra of the paracetamol. So that is this one, and compare this. We can able to see the impurities in this type. The graph we can get this in the digital display, and we can able to see the impurities from this. And similarly we can detect the functional group. So for the benzene like this, for the toluene, so it is we can able to from this wavelength we can also detect the functional group with the help of this spectrophotometry. So this is about the application part. So this is by using this spectrophotometer we can able to deduce the qualitative and quantitative assessment of a solute dissolved in a solution using a spectrophotometer. Thank you.